With problem number 9, we're given the function f is equal to x to the fourth plus x squared minus 2, and we're asked when is f increasing. So we have to go with our first derivative test here. Okay, this is a first derivative test problem. We are interested in figuring out when our derivative is positive, because a positive derivative means an increasing function. So let's get our derivative for starters. F prime of x, using our regular rules, 4x cubed plus 2x will be our first derivative. Now that we have our derivative, we set it equal to 0. The nice thing about these problems is trying to factor out something common, so we have a product and we can use the zero product law. These two terms have a 2x in common, and 4x cubed divided by 2x is 2x squared. 2x divided by 2x is 1. So now we need to figure out when these two terms are equal to 0. So we cover them up one at a time. When we cover up the second term, we have 2x equal to 0, which obviously means that x equals 0 is one of our critical numbers. When we cover up the 2x, we have 2x squared plus 1 is equal to 0. Now the eagle-eye observer will notice right away this is never going to be true. Right? We can't square something which has a minimum value of 0, double it, and then add 1 and get 0. It's not possible. But in case you don't see that right away, no big deal. 2x squared plus 1 equals 0, so we would have over here on the side 2x squared plus 1 equals 0, and then you take the 1 over to the other side, and then you divide by 2, so you have x squared equals negative 1/2, and then you would take a square root. And when you try and take a square root of a negative number, that should set off your red flags. We know that this x equals 0 is our only critical number, which means that C and A are automatically out, and it's either going to be B or D. But we need our first derivative test. We need our plus minus chart. So there's 0. We're going to plug in any number to the left of 0. So let's plug in something like negative 1. And when we plug in negative 1 over here, 2 times negative 1 is a negative. And we know that this is always positive because it's a square plus 1. So we have a negative times a positive, which is a negative. And then we plug in a positive value, like 1. 2 times 1 is positive. And this is still positive. Positive times a positive is a positive. Positive derivative correlates with an increasing function. So our answer is from 0 to infinity, or B. With number 10, f is now a function with derivative x squared minus 2 over x. Which of the following intervals is f decreasing? Right? Function's decreasing when the derivative is negative. So we're doing the same thing as the previous problem. We have to find our critical numbers. So here's our value, our derivative right up here. Right away we see that x equals 0 is an issue, because if x is 0, our derivative does not exist. And critical numbers occur when the derivative is equal to 0 or does not exist. We have to find out when, if at all, this function is equal to 0. So we can start our equation. Well, there's not much we can factor out of these two, but we can move the 2 over x over to the other side by adding it to both sides. And that allows us to basically cross multiply. We have x squared over 1 is equal to 2 over x. So by cross multiplying, we see that we have x cubed is equal to 2. And therefore, x is equal to the cubed root of 2. Hence, the reason why you're seeing that is a couple of the answers. So we've got x equals 0 and x equals the cube root of 2. Those are our two critical numbers. So we're going to throw them on a number line. Right, 0 here. And cube root of 2, not really sure what that is, but I know that it's positive. So I'll put cube root of 2 right there. And we need some values in between. Well, we can do something like negative 1. And this can be something like 4. The question is, what number goes in between here? Well, the cube root of 1 is 1. The cube root of 2 is bigger than that, so I know that I can use 1 as a test value here. So let's plug our numbers into the first derivative. If I plug in negative 1, I have a positive value minus 2 over negative 1. So minus a negative, which is a positive. So I have a positive plus a positive. So we're talking positive right here before 0. When x is 1, I end up with 1 minus 2. That's a negative value. And when x is 4, I have 16 minus 2 over 4. 2 over 4 is a half. 16 minus a half is a positive value. So positive right there. So a negative first derivative means a decreasing function, so we're going from 0 to the cube root of 2, and there is our solution. Now notice that the readers decided to use a closed bracket here, which is fine. It had to be an open bracket here because the derivative does not exist at x equals 0. And then finally with number 11, all right, we're asked for an inflection point. Inflection points occur when the second derivative changes sign. Here's our second derivative. We need to figure out when this second derivative is equal to 0. So once again, we're going to cover up our products one at a time. We see 2 as an answer. We see negative 1 as an answer. And we see that 0 is an answer. So x equals 0, negative 1, and 2. We can throw these on a number line. Negative 1, 0, and 2. So number to the left of negative 1, like negative 4. Negative 4 here would be negative. Negative 4 plus 1 is a negative. This is being squared, so no matter what, this will always be positive. Okay. Negative times a negative times a positive is a positive. Now we plug in a number like negative a half. Negative half will be negative. Negative half plus 1 is positive. We know this is positive. Negative times a positive is a negative. Now we plug in 1. 1 here is positive. 1 plus 1 is positive. That's positive across the board. And finally we plug in 3. That's positive. 3 plus 1 is positive. This is positive also across the board. So a point of inflection will occur when the second derivative changes sign. Changes sign from positive to negative here. Changes sign from negative to positive here. Negative 1 and 0 only, not 2.